silence. Not the peaceful kind. The kind that makes your ears ring. The kind where you can hear your own heartbeat getting louder and louder until it's the only sound in the universe. That's what Oppenheimer heard in the seconds before the first atomic bomb detonated. Complete silence. 10 miles away from ground zero, lying flat on the desert floor with his face pressed against the cold sand, waiting for something that had never happened before in the entire history of Earth. And all he could hear was nothing. Just his breathing. Just his pulse. And then, in less time than it takes a hummingbird to beat its wings once, everything changed. Not just for him. For everyone. Forever. Because once an atom splits, once that process begins, there is absolutely no way to stop it. No brake pedal. No emergency shutdown. No takebacks. The atom doesn't care if you changed your mind. It doesn't care if you're scared, or if you realize you made a mistake, or if you suddenly understand the full weight of what you've done. The physics just runs its course, and that course happens so fast that by the time your brain registers that something's wrong, entire cities could already be ash. And here's the thing that's going to mess with your head. Oppenheimer knew this before he pushed the button. He'd done the math. He'd calculated exactly how fast the reaction would spread, how many atoms would split in the first microsecond, how much energy would be released, how hot the fireball would get, how far the shockwave would travel. He knew all of it, and he did it anyway. Not because he was evil, not because he didn't understand the consequences, but because once you discover that atoms can be split, once you realize that the process is self-sustaining, once you understand that every heavy atom is essentially a tiny bomb just waiting for the right trigger, you can't undiscover it. The knowledge exists, and knowledge has this terrifying property, where it spreads faster than any chain reaction, faster than any explosion, because you can't kill an idea, and you can't uninvent physics. So when Oppenheimer saw what happened inside the atom that morning in the New Mexico desert, when he witnessed matter transforming into energy on a scale that had only existed inside stars, he didn't just see a successful test, he saw the end of human innocence. He saw the moment we became capable of our own extinction. And if you're the kind of person who wants to understand how we got here, how a bunch of scientists accidentally discovered something that made genocide as easy as pressing a button, hit subscribe right now, because what I'm about to show you is going to change how you see reality itself. This isn't a story about politics or war. This is a story about what happens when you look inside an atom and discover that the universe has been hiding the most dangerous secret in existence right under our noses for the entire history of matter. Now you're probably thinking atoms are these tiny, stable things that just sit there, being solid and reliable. I mean, that's what they taught you, right? Matter is made of atoms. Atoms are the building blocks of everything. They're permanent and stable and predictable. Your textbook probably showed you that diagram with the nucleus in the middle and the electrons orbiting around it. Nice and neat, like a little solar system. And for most atoms, that's basically true. The carbon atoms in your body, the oxygen you're breathing, the silicon in your computer, they're just hanging out, being atoms, not causing any problems. They've been stable for billions of years, and they'll be stable for billions more. So when you first hear about nuclear fission, about splitting atoms, it sounds impossible. How do you split something that's supposed to be indivisible? The word atom literally comes from the Greek word atomos, meaning uncuttable, indivisible, the smallest possible thing. For thousands of years, people believed atoms were the end of the line, the fundamental units that couldn't be broken down any further. Except here's the problem. They were wrong. Atoms can absolutely be split. But not all atoms. And this is where it gets interesting. See, there's a specific type of atom that's basically a ticking time bomb. Uranium-235. This atom has 92 protons and 143 neutrons crammed into a nucleus about 10 to the negative 15th meters across. That's 0.000000000000001 meters. It's so small that if you could blow up a uranium atom to the size of a football stadium, the nucleus would still only be about the size of a marble sitting in the center of the field. But here's what's crazy. That tiny marble contains 92 positively charged protons, all pushing against each other with incredible force. Protons repel each other. That's basic physics, like charges repel. So you've got 92 particles crammed into this impossibly small space, all trying to escape from each other, all pushing outward with electromagnetic force. The only reason they don't fly apart immediately is because there's another force holding them together. The strong nuclear force. And this force is powerful. Way more powerful than electromagnetism, but it only works at extremely short distances. If you pull the nucleus apart, even slightly, even by distances smaller than the nucleus itself, the strong force weakens, and the electromagnetic repulsion takes over. And that's when things get explosive. Because uranium-235 is right on the edge. It's barely stable. It's like a boulder balanced on the top of a mountain. The slightest push, and it tumbles down. And when it tumbles, it doesn't just fall. It splits. And when it splits, something extraordinary happens. It releases neutrons, fast-moving neutrons. And here's where Oppenheimer realized something that changed everything. Those neutrons can hit other uranium atoms. And when they do, those atoms split too. And they release more neutrons, which hit more atoms, which split and release more neutrons. And suddenly, you don't have one atom splitting. You have 2, then 4, then 8, then 16, then 32, then 64, then 128. And this doubling happens in billionths of a second. This is called a chain reaction, and once it starts, there is absolutely nothing you can do to stop it. Picture this. You're standing in a massive warehouse. The floor is covered, wall to wall, with mousetraps, millions of them. And on each mousetrap, balanced carefully, is a ping-pong ball. The whole warehouse is quiet, still, stable. Everything's just sitting there. Now imagine you take one ping-pong ball and drop it. It hits a mousetrap. Snap. The mousetrap springs and launches its ping-pong ball into the air. That ball comes down and hits another trap. Snap. Now you've got 2 balls in the air. They hit 2 more traps. Snap, snap. Now 4 balls. Snap, 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 snap. 8 balls. And within 2 seconds, the entire warehouse is chaos. Thousands of traps snapping. Thousands of balls flying. A roar of mechanical violence. That's a chain reaction. But that's just mousetraps. Now, imagine the same thing, but instead of ping-pong balls, you've got neutrons. And instead of mousetraps, you've got uranium atoms. And instead of a ping-pong ball flying through the air, you've got particles moving at 10 million meters per second. And instead of a snap, you've got an atomic nucleus ripping itself apart and releasing 200 million electron volts of energy. That's the energy of a lightning bolt concentrated into something 10 trillion times smaller than a grain of sand. And it's happening to billions of atoms simultaneously. Let me give you a sense of the scale here. 1 kilogram of uranium-235 contains approximately 2.5 times 10 to the 24th atoms. That's 2.5 septillion atoms. Now imagine you've got enough uranium that when you start the chain reaction, every single one of those atoms splits within 1 millionth of a second. Each atom releases about 3.2 times 10 to the negative 11th joules of energy. Multiply that by septillions of atoms, and you get something like 8 times 10 to the 13th joules. That's roughly the energy of 20,000 tons of TNT exploding at once, from 1 kilogram of metal. And that explosion happens faster than you can blink, faster than you can think, faster than any possible human reaction time. This is what Oppenheimer understood. He understood that the chain reaction is inherently unstable. It grows exponentially. Each generation of splits happens faster than the last because there are more neutrons available to trigger more splits. In the first generation, one atom splits and releases 2 or 3 neutrons. In the second generation, those neutrons hit 2 or 3 atoms, which split and release 4 to 9 neutrons total. Third generation, you've got 9 to 27 neutrons. Fourth generation, 27 to 81. By the 50th generation, which happens in less than 1/1,000,000th of a second, you've got more neutrons flying around than there are stars in the galaxy, and every single one of them can trigger another split. There's no off switch. There's no way to absorb all those neutrons. There's no way to slow it down. Once critical mass is achieved, once you've got enough uranium in one place that the neutrons can't escape without hitting another atom, the reaction becomes self-sustaining and inevitable. Now here's where Oppenheimer's genius comes in, and also his curse. He didn't just understand the physics theoretically. He figured out how to make it happen in practice. And while you're wrapping your head around that, drop a comment telling me where you're watching from, because I'm genuinely curious how many people around the world are trying to understand this stuff. The challenge wasn't splitting one atom. Scientists had been doing that in laboratories since 1938, when Otto Hahn and Fritz Strassmann first discovered fission. The challenge was making the chain reaction happen fast enough and completely enough to release all that energy before the uranium blew itself apart. See, here's a problem nobody talks about. When uranium starts splitting, it gets hot. Really hot. Hot enough that the metal vaporizes instantly. And when it vaporizes, the atoms spread out. They're no longer packed tightly together. And if they're not packed tightly, the neutrons can escape without hitting another atom. The chain reaction stops. You get what's called a fizzle, a pathetic little explosion that releases maybe 1% of the potential energy. This is why building an atomic bomb is actually harder than people think. You can't just pile up uranium and expect it to explode. You need to compress it. You need to squeeze the uranium into a super-dense configuration where the atoms are packed so tightly that neutrons absolutely cannot escape. And you need to do this compression faster than the uranium can blow itself apart. Oppenheimer and his team at Los Alamos spent 3 years figuring this out. They tried different designs, different configurations. They ran calculations on mechanical computers that filled entire rooms. They built test devices. They argued about physics. They worked 18-hour days, 7 days a week, fueled by coffee and cigarettes, and the absolute certainty that if they didn't build the bomb first, Germany would. And what Oppenheimer discovered, what kept him up at night, was that it was possible. Not just theoretically possible, practically achievable. They could take uranium, compress it using conventional explosives arranged in a perfect spherical shell, and create a chain reaction that would release the energy equivalent of 20,000 tons of TNT in less than 1/1,000,000th of a second. The math worked. The physics was sound. And once they realized it could be done, once the knowledge existed in their minds, there was no way to make it not exist. Knowledge doesn't have a delete button. You can't unlearn physics. You can't forget equations. And this is where the moral weight started crushing Oppenheimer. Because he knew that once they proved it was possible, Once they demonstrated that a small team of physicists could build a weapon capable of destroying an entire city, that knowledge would spread. Other countries would figure it out. The Soviet Union, China. Eventually, any nation with enough resources and determination could build their own bomb. The secret wasn't in some magical rare material. Uranium exists in the ground. You just have to purify it. The secret was in understanding the physics of the chain reaction. And that secret, once discovered, could never be contained. Let me tell you about July 16, 1945, the day everything changed. Oppenheimer and his team had built the first atomic bomb. They called it the Gadget. 64 kilograms of plutonium-239, a different fissile material but with the same basic properties as uranium-235, surrounded by conventional explosives designed to compress it into a supercritical mass. They transported it to a test site in the New Mexico desert called Trinity, named after a poem by John Donne that Oppenheimer loved. They assembled it on top of a 100-foot steel tower. And then they waited. The test was scheduled for 5:30 in the morning. Oppenheimer barely slept the night before. He chain-smoked. He paced. He went over the calculations again and again. Some of the scientists were worried about something called atmospheric ignition. They'd calculated that there was a small chance, maybe 1 in 3 million, that the heat from the atomic explosion could trigger a fusion reaction in the nitrogen in the atmosphere. And if that happened, if the atmosphere itself started burning, the reaction could spread across the entire planet. The whole Earth could become a star for a few seconds before all life was incinerated. They discussed this. They argued about the probability. And they decided to proceed anyway. Think about that. They knew there was a chance, however small, that the test could end all life on Earth, and they did it anyway. Because the math said it probably wouldn't happen. Probably. At 5:29 and 45 seconds in the morning, the bomb detonated. Oppenheimer was lying in a trench 10 miles away, his face pressed into the sand. And then came the flash. A light brighter than 1,000 suns. Brighter than anything any human had ever seen. The desert turned to daylight. People reported seeing the flash from 100 miles away. The light lasted for several seconds, and in that light, Oppenheimer saw something that no human had seen before. He saw matter becoming energy. He saw the equation E equals mc squared made real. Every atom of plutonium that split released energy according to Einstein's formula. The mass of the plutonium didn't disappear. It converted. Mass and energy are the same thing, just in different forms. And the conversion rate is the speed of light squared. 3 times 10 to the 8th meters per second squared. That's 9 times 10 to the 16th. That's 90 quadrillion. So even a tiny amount of mass, when converted to energy, releases an ungodly amount of power. The Gadget converted about 1 gram of matter into pure energy. 1 gram. About the weight of a paperclip. And that 1 gram created an explosion with a yield of 22,000 tons of TNT. The fireball reached a temperature of 100 million degrees Fahrenheit. That's hotter than the core of the sun. The shockwave shattered windows 100 miles away. A mushroom cloud rose 8 miles into the sky. And in the moments after the explosion, as the light faded and the sound reached them, a rolling thunder that seemed to come from everywhere at once. Oppenheimer stood up. His colleague Kenneth Bainbridge turned to him and said, "Now, we are all sons of bitches." But Oppenheimer was thinking of something else. A line from the Bhagavad Gita, the ancient Hindu scripture he'd studied and loved. "Now I am become death, the destroyer of worlds." He didn't say it out loud at that moment. That came later. But he was thinking it. Because he understood what he'd just done. He'd proven that humans could harness the power that fuels stars. He'd shown that the energy holding atomic nuclei together could be released and weaponized. And he knew, with absolute certainty, that this was just the beginning. And this is what haunted Oppenheimer for the rest of his life. What kept him awake. What made him look older than his years. What eventually broke him. He realized that when you split an atom, you're not just breaking a physical object. You're crossing a threshold. You're demonstrating that the fundamental forces of nature can be controlled and directed. And once you've crossed that threshold, you can't go back. The knowledge exists, the capability exists. And here's the truly disturbing part. The physics doesn't care about morality. An atom doesn't split differently if you're building a weapon versus generating electricity. The chain reaction doesn't know if you're a good person or a bad person. It just happens. Neutron hits nucleus, nucleus splits, energy releases, more neutrons fly out. That's it. That's the whole process. And it's so simple that once you understand it, once you really get it, you realize how fragile everything is. Every atom in your body right now contains energy, enormous energy. The atoms in your hand, if you could somehow convert all their mass to energy, would create an explosion bigger than the bomb that destroyed Hiroshima. You are made of potential bombs. We all are. Every piece of matter is just energy in a stable configuration. And some configurations are more stable than others. Carbon is stable. Iron is stable. But uranium, plutonium, they're sitting on the edge of stability, one neutron away from catastrophe. And Oppenheimer understood that this wasn't unique to uranium. As physics progressed, as scientists probed deeper into the nucleus, they discovered that you could also fuse atoms together, combining hydrogen into helium the way the sun does, and release even more energy than fission. The hydrogen bomb. Fusion weapons. Thermonuclear devices capable of yields measured in megatons, millions of tons of TNT equivalent, thousands of times more powerful than the bombs dropped on Japan. And the same physics that makes the sun shine makes these weapons possible. There's no separate evil physics and good physics. It's all the same physics. The same equations that explain why stars burn also explain how to build a device that can erase entire cities in milliseconds. This is what broke Oppenheimer. After the war, after Hiroshima and Nagasaki, after 140,000 people died in Hiroshima and 70,000 in Nagasaki, after he saw the photographs of the destruction, the shadows burned into concrete where people had been standing when the flash hit them, the keloid scars on survivors, the children with radiation sickness. He started speaking out against nuclear weapons. He opposed the development of the hydrogen bomb. He argued for international control of atomic energy. He tried to put the genie back in the bottle, and the government he'd served, the country he'd helped save, turned on him. In 1954, they held a security hearing. They brought up his communist associations from the 1930s. They questioned his loyalty. They revoked his security clearance. They humiliated him publicly. And through it all, Oppenheimer maintained that the physicists had known sin, not because they'd done evil, but because they'd acquired knowledge that made evil easier. They'd discovered something about nature that couldn't be undiscovered. And that knowledge, that understanding of how to release the energy in the nucleus, would spread inevitably across the world. You're sitting there right now, made of atoms, trillions upon trillions of them. Every breath you take brings in oxygen atoms. Every bite of food you eat adds more atoms to your body. And inside each of those atoms is a nucleus, held together by forces so powerful that if you could somehow release all that energy at once, you'd become a flash of light brighter than the sun. You are, in the most literal sense, made of trapped energy. Matter is just energy in slow motion. And the amount of energy trapped inside you, inside the atoms that make up your cells and bones and blood, is staggering. If you weigh 70 kilograms and you could somehow convert all of that mass into energy, you'd release about 6 times 10 to the 18th joules. That's 6 quintillion joules. That's the energy equivalent of 150 billion tons of TNT. That's about 3 billion times the energy of the Hiroshima bomb. Inside you, right now. Obviously, you're not going to explode. Your atoms are stable. The carbon and oxygen and nitrogen that make up most of your body mass are in configurations that don't undergo fission. They're happy being atoms, but the principle remains. You are energy. Energy pretending to be matter. Energy organized into patterns that can think and feel and wonder about their own existence. And when Oppenheimer looked at the atom, when he really understood what it was, he saw this. He saw that the universe had been hiding an almost infinite source of power in the most fundamental building blocks of reality. And he saw that humans, curious and clever, and sometimes cruel, had figured out how to access that power. He saw that we'd crossed a line. Before Trinity, destroying a city required thousands of bombers dropping thousands of tons of explosives over weeks or months. After Trinity, one bomb, one airplane, one mission. The scale of possible destruction had jumped by orders of magnitude, and it would only get worse. The hydrogen bomb proved that. The arms race proved that. At the peak of the Cold War, the United States and Soviet Union had tens of thousands of nuclear weapons pointed at each other. Enough to destroy human civilization many times over. Enough to create a nuclear winter that would kill most life on Earth. And all of it traced back to that moment in the desert when Oppenheimer and his team proved that splitting atoms could release enough energy to level a city. They didn't create the physics. The physics was always there, built into the structure of matter itself. They just discovered it. They just figured out how to make it happen on demand. And that's the unbearable weight Oppenheimer carried. He knew he hadn't created something evil. He'd uncovered something that had been there all along. The capacity for destruction was baked into reality from the moment the first atoms formed in the early universe. All he'd done was reveal it. So next time you look at your hand, think about this. You're looking at energy, condensed energy, frozen energy. Energy that's moving so slowly it appears solid, but it's not solid. It's never been solid. It's vibrations in quantum fields. It's probabilities and wave functions and uncertainty. It's electrons buzzing around nuclei so fast they're everywhere and nowhere at once. And inside those nuclei, protons and neutrons held together by forces we still don't fully understand, containing energy we've barely learned to harness, waiting, stable, quiet, until something comes along and breaks them apart. And when they break, when the strong force lets go and the nucleus splits, all the trapped energy releases in a microsecond, and matter becomes light and heat and shock waves and radiation. Oppenheimer saw this. He understood it with a clarity that terrified him. And he spent the rest of his life trying to make people understand what he'd seen. Not just the technical details, not just the equations and the physics, but the existential truth. That we live in a universe where matter is energy in disguise, where the difference between a peaceful atom and an explosive one is just a matter of which element you're looking at, where the power to create and the power to destroy come from the exact same source. The strong nuclear force doesn't care if you're building a reactor to power homes or a bomb to destroy them. The physics is identical. The only difference is intention. human choice, human wisdom, or lack thereof. And that's what kept Oppenheimer up at night, because he'd seen what humans do with power. He'd seen war. He'd seen hatred. He'd seen how quickly good intentions turn into justified atrocities. And he'd given humanity a power that could end everything. Not might end everything. Could. The capability existed. The weapons existed. The delivery systems existed. All it would take is one miscalculation, one misunderstanding, one leader having a bad day, and the bombs would fly. And once they started flying, there would be no stopping it. Just like there's no stopping a chain reaction once it reaches critical mass. The first bomb launches. The radar picks it up. The other side retaliates. More bombs launch. Within 30 minutes, hundreds of warheads are in the air. Within an hour, every major city in multiple countries is gone. Within a day, the fires and radiation have killed hundreds of millions. Within a week, the smoke and ash block out the sun and temperatures drop globally. Within a month, crops fail and famine begins. Within a year, civilization collapses. And all of it traces back to the moment Oppenheimer figured out how to make atoms split on command. He didn't want this. He was trying to stop Hitler. He was trying to end a war. He thought if America had the bomb first, it would create a deterrent, make future wars impossible because the cost would be too high. But deterrence only works if everyone's rational. And history is full of irrational actors, full of mistakes, full of accidents that spiral into catastrophes. So when you ask what Oppenheimer saw inside the atom, the answer is everything. He saw the structure of matter. He saw the energy that holds reality together. He saw the process by which that energy could be released. He saw the chain reaction that makes release irreversible. He saw the engineering challenges and how to overcome them. He saw the flash in the desert and knew what it meant. He saw Hiroshima and Nagasaki reduced to ash. He saw the future where nuclear weapons proliferate across the globe. He saw the possibility of human extinction. And he saw that none of it could be undone. The knowledge existed. The capability existed. The weapons existed. And once something exists, you can't make it not exist. You can't uninvent the atomic bomb any more than you can unsplit an atom once it's been split. The process runs its course. The energy releases, the explosion happens, and all you can do is watch and hope you made the right choice. Can you look at the world the same way after knowing this? Can you touch solid objects without remembering they're mostly empty space held together by forces that could, under the right circumstances, tear themselves apart and release enough energy to vaporize you? Can you trust that the people who control these weapons will never use them, despite the entire history of humanity suggesting that if a weapon exists, eventually someone fires it? If your mind got blown today, smash that like button. So I know this stuff resonates. Subscribe if you want to keep exploring the physics that changed everything. And drop a comment telling me which discovery you want me to dive into next. The fusion bomb? The neutron? Quantum tunneling? Let me know. Thanks for watching.